So merge is very much a column-based operation, inspecting the data content. Now, at times, when we have specified to all the sources, or because we control all the data frames, we consistently label them correctly. D is the vaccination date and D is the vaccination date. So it's very correct in meaning. Then we don't have to really say left on D and right on D. And all we need to do is to be able to just say on D, and that's it. So it's more like a shortcut. Yeah, so we have a on D here, and the meaning is the same. It's just saying left on D, comma, right on D. So we look at D and D, and interestingly now, we see that when we look at the content of the D and the D, it's 2,8, right? And because it's how is the inner, meaning intersection, so it's 2,8 only, then all we do is copy the rows. So 2,8 will keep, and then we have the 3 and the 6. And because we are having D on D, we are going to retain the column C, not column D, because we already have D. So we're going to retain the column C, and we have this. Interesting? Okay. Now, finally, what if we say on D but it's outer? Then what's going to come out of it? So remember, it's column based, so we don't change the column. So we look at outer. We look at D and D. There are duplicated or common parts, right? So we will keep 2789, 2789. Okay, and then of course we'll keep B, but because there is a D here that says 2 and 8, so for the parts where there's a common 2 and 2, the C value will be the 2, will be correctly here. But in the second row where D has 7, C is we're not having a D column with the second row being 7, right? So it's undefined. So fill a that. And correctly, in the third column, the D value is a 8, which gels with this. Notice that it now goes by content equivalence. So this is exactly the time when C has the value 7, so we put a 7 here. And finally, there's a 9 that DF2 doesn't have, so put a 9. So all this looks very logical, provided, of course, you understood what it inherently means. Now, always go to Pandas documentation. So just Google for Pandas, let's say merge. And the first item usually is, is the documentation because so many people search for it. Don't try to memorize all this. I do hope that while going through this and later on with the lab experiment, you can internalize this, it becomes automatic. But never try to memorize left on, right on, like, it doesn't help because you're going to feel so burdened and you might even recall wrongly, and that's dangerous. So do feel natural, even for pros and seasoned programmers, do feel natural to just look it up in the documentation. Next, and finally, for this session, we look at dot join, right? So dot join looks at columns. So it's a bit like merge. But unlike merge, it doesn't look at the column data. It looks at the row index value. The row index value, very strangely, all right? So while merge is kind of designed for column-based, join, on the other hand, kind of, you can say, is more sensitive to the row labels, the dot index labels. So let's take a quick look. Again, we create the same differently sized and intentionally programmed data like that. So df1, df2. When we run df1 dot join with df2, okay, there's also a sense of left on and right on. Left on and right on, except we don't say that. We say L suffix and R suffix. So what it means is the sort of disambiguating suffix for the columns. Remember, this is a very row-based joining operation. So row-based joining operation simply means that as a result, the row labels will not duplicate. So we have the common row labels 0, 1 and 0, 1 here. They will be sort of combined in some sense with the columns extended if necessary. And exactly as it appears here, 3, 2, 1, 7, right? Okay, and because the row labels correspond, yeah, and we detected, right, that there are additional data here, so C and D, and the D is duplicating the column label D in DF1, and so we have to disambiguate, and so when we do that, we have supplied the underscore left and underscore right. You can change it to anything you like, underscore X, underscore Y, no problem. So left suffix right to disambiguate the new labels, the new column labels that is being detected. And it's always column labels because join is a row-based operations. Notice that we are specifying how to handle the row index values. It's based on union, so outer, which means that when we are done with 0, 1, we're not yet done because we have 2 and 3. So we would just wholesale copy them and fill in the nands where there are no more values. When we join the columns by index, okay, we need to make sure that the columns, the indices, the index values here are saying what we want to say, because join is sensitive to the index values. Okay, sometimes we may want to actually use the data values to align and join based on data values row wise. So it's like we want join to behave like merge, except merge is designed for column based kind of merging, but we want row based kind of merging, can or not. And answer is can, but with a bit of trick. We're going to park, all right, we're going to borrow the dot index of the data frame to be the content value of the column that we want the rows to be based on. Okay, so in other words, we're going to borrow dot joins sensitivity to the index values and use our column data to plonk it into the dot index. And the way to do it is simply just say df1 dot set index the D label. So this is df1, and put the entire column D into the dot index. And at the same time, removing that so that there's no duplicate processing. Now, in case you feel that you might lose column D, you can always make a copy of it in a series, right? So set index this, and set index is not only just copying, it also deletes away the column D so that the data is already there, but it's now more sensitive to dot join. It's ready for dot join to inspect. Likewise, we ask or we create a data frame that sets the column D, all right, into the index, thereby retaining only column C, and the column D data goes into the dot index. So now we call that df1k and df2k. Now we are ready to sort of merge by looking at the data content of our original D, but they have been set into the dot index, right? So we're going to say df1k, this one, not the upper one, the lower one. df1k dot join with df2k, this one. What's going to happen is that, the how is outer, so we union it. What's going to happen is dot join, remember, it does only one thing. It looks at the index content, index value, index labels. 2 and 2, right, good, right? 7, 8, 8, 9. Well, basically 2, 7, 8, 9 contains 2, 8. So we'll just look at 2, 7, 8, 9. So 2, 7, 8, 9, the B column, or if you have X, Y, Z, no problem. They will just be copied over. Then comes these columns. The 2 and the 8 will occur at the 2 and the 8. All right, not the first row, second row, but based on the index. That's what we call by the dot join is being sensitive to the index labels. So it's going to really look at the labels and say 2, okay, that's the first row. 8, however, is the third row here. Yeah. And in between, nothing, no data is supplied by the DF2K. So we're going to fill in with NAS. Let's try the same thing quickly with inner joins. So everything is the same. We are going to look at the dot index labels, the intersection of 2789 and 28. Yeah. So we will look at 28. And for the first column B, the 2 has the row 2, value 3, 8, value 6. So 3, 6. And for C, the DF2K is quite easy because just copy. Okay, so by that, we would now expand our abilities to be able to create monstrous data frames by summoning smaller data frames, piece them up by positioning them, piece them up by looking at the content of the columns, right? Piece them up by looking at the content of the rows, right? And using dot concat, dot merge, dot join. Let's move over to our lab. Come join me.